What's up, guys? It's Probability by Pitman, Chapter 1, Review Section, number 11, Problem 11. Alright, so the problem is saying a hat contains n coins, f of which are fair and b of which are biased to land heads with probability 2/3. The coin is drawn from the hat and tossed twice. The first time it lands heads, and the second time it lands tails. Given this information, what is the probability that is a fair coin? So first, let's draw a tree diagram to represent the situation. So I guess first we pick a coin from the hat. So that's our first scenario. So we'll write F and B. The probability of a fair coin is F over N. Probability of a biased coin is B over N. So that's our first scenario where we pick what coin. There we can say the probability it lands heads in the first flip, the probability it lands tails in the second flip, probability it lands heads in the first flip, probability it lands tails in the first flip. So for a fair coin, it'd be half. Half. For a biased coin, it would be 2/3, 1/3. Then we do the same thing for the second flip of the coin. Sorry for that messy tree. Alright, cool. So now that we have a basic tree diagram, let's try and do the actual problem. So they're asking us, what is the probability that is a fair coin given the information that it lands heads the first time and tails the second time? Let's write it like this. H1, tail 2. So heads first, tail second. Okay, so you'll notice that the way we drew our tree, we're going, if we were to do it in this order, we'd be going up the tree, right? Because normally, since we're trying to go up the tree, this is a pretty ideal time to use Bayes' rule, which I'll write it again. Then I'll write our probability into Bayes' rule. Okay, cool. So you'll notice that now our order for the given is flipped, and now we're actually going to be working down the tree, which is a lot easier and more natural for us to do. So that's why Bayes' rule is useful, because we're flipping how we're using the tree, and it's much more intuitive. Okay, so probability of H1T2 given fair. That's pretty simple. So given fair, which is F over N, then H1T1 or H1T2 is just going to be F over N times half, where this is the probability of getting fair, this is the probability of getting heads first, the probability of getting tails second. Alright, times the probability of fair, which is F over N. Oh, sorry, I completely forgot. We have to deal with, let's write P over fair. Because it's given, right? So we have to divide by probability of fair. And times F over N, you'll see that they cancel. And then we have to divide by the probability of H1T2, which is going to be a little different because we have to do F over N times half. Plus, and then we have to have the scenario where you get a biased coin. So heads first and then tails second. So B over N times 2/3 times 1/3. Okay, cool. And then if we simplify this further, we'll get um, and that should be our answer. All right, cool. I hope that helped, and yeah.